so today, again, we're multiplying monomials. We're going to look at two things. We are going to do the product of powers and the power of a power. Today, a lot of our problems are going to look like this. Something like that, x squared to the fifth power. X squared to the fifth power. So what I'm going to call this is a power to another power. Okay, a power is an exponent. So I'm taking one exponent and I'm raising it to another exponent. And we're going to learn a trick for that. I'll show you that here in a second. But that's the gist of what we are exploring today. So if we have something like x squared to the fifth power, that means we have how many x squareds? 5 of them, right? How many x squareds do we have? We have 5 of them. So I could write this out as x squared times x squared times x squared times x squared times x squared. So we have 5x squares. Yesterday we learned what to do if we have it like this, didn't we? What did we learn yesterday to do with those exponents? Add them. So what is 2 plus 2 plus 2 plus 2 plus 2? 10. X to the 10th power. Now back in elementary school when you guys were first learning about addition and multiplication, what did you learn when you have repeated addition, 2 plus 2 plus 2 plus 2 plus 2? You could change that into what? 2 times 5. Didn't we learn about multiplication? When you first learned about multiplication, your teacher probably had you do things like that. 2 plus 2 plus 2 plus 2, 5 times. And then she said, well, we could just take 2 times 5, which is 10. Okay. And that's the trick that we're going to apply today. If we have a power and we're taking it to another power, we're going to multiply those exponents. What if we have y to the 4th cubed? That would be like how many y to the 4ths? 3 of them, right? 3 y to the 4ths? So that would be like y to the 4th times y to the 4th times y to the 4th. Yesterday we learned if we have the same base and we're multiplying, we add the exponents. We do 4 plus 4 plus 4. Or we could do 4 times 3. Repeated addition is just multiplication. 4 times 3 is 12. Any questions so far? Look at this, not this one, I understood that. This one. We have a to the 5th to the 6th power. My base a is being raised to the 5th, and then I'm going to raise it to the 6th power. So this would simplify to what? A to the 3rd. It might be helpful in your notes, just for this first problem, write 5 times 6, so that if you're looking back in your notes, you know how you got 30. A to the 30th power. Now we can incorporate yesterday's rule into today's new rule as well. And that's what we're going to do in this next example. X squared to the 5th power times x to the 7th power. Make sure you write it down correctly so it makes sense. X squared to the 5th power times x to the 7th power. Now, I want you to make sure you know what to do first. Remember PIMBIS? That hasn't gone anywhere. That's still very much a part of our problem. We want to do exponents before we do multiplication, correct? So what do I mean by exponent? Well, I mean that right there. What is x squared to the 5th power? X to the 10th power, correct? So I'm going to just change that to x to the 10th power. Now I still have x to the 7th that was part of my original problem. This is what we did yesterday, isn't it? What are we going to do with those exponents if we're multiplying? We add them. So x, 10 plus 7 is 17. X to the 17th power. coefficient. Go ahead and copy this down. We're going to look at a couple variations of this problem here. So we have negative 2, parentheses, AB squared, all to the 4th power. I know we've talked about the little magic fairy here, right? Have I mentioned the magic fairy in here? No? No? You guys are missing out. Okay. So let's back up for a second. I want you to think of an exponent as a little magic fairy. Fairies go around zinging stuff, right? They have their wand and they reach out and they say zing or what, I don't know what they say. But they go around and they zing stuff and they change it. So this is our little fairy here, this 3. And that 3 has a little magic wand. That 3 is zinging the X, right? Now if I had something like this, that fairy is zinging, this time, she's zinging the whole parenthesis. So everything's going to get zinged, everything's going to get cubed. If we have this, that 3 is still zinging the parenthesis, but is it zinging the 2? No, it's not inside of the parenthesis. So as you go through these problems, I need you to make sure you ask yourself, okay, what is that little fairy zinging? Is it zinging the parenthesis? Is it just zinging that one variable? Is it zinging everything? You'll have to make that connection. You never thought you'd talk about little fairies in algebra, did you? Okay. So hopefully that'll help you to remember what you're supposed to be taking to a power and not. So in this third example, what is that 4 zinging? Everything inside the parentheses. Now, I'm going to drop my little wand in there. That 4 is zinging the parentheses. That means everything in the parentheses is going to get taken to the 4th power. What about the negative 2? Does it get taken to the 4th power? Why? It's not inside the parentheses. So what I'm going to do is just bring down the 2. I'm not going to do anything with it. Bring down the 2. When I take A, what's the exponent on that A? On the A? It's just a 1. The B is a 2. So I have A to the 1st to the 4th power. You could think of that as A to the 1st to the 4th power. What's that really going to become? A to the 4th power, isn't it? 1 times 4 is 4. So write that as A to the 4th power. I have B squared, and I'm taking that to the 4th power also. What is that going to become? B to the 8th. This right here is what you're going to be thinking about in your head. Okay? If you need to write it out to visualize it, please go ahead and write it out. But that's the thought process that I want to happen in your head as we go through these. This next example is similar but not the same. So this time I have in parentheses negative 2 AB squared all to the 4th power. So this time that exponent of 4 is zinging what? Negative 2, the A, and the B squared, correct? So it's going to go to everything. Zinging the parentheses. So everything inside the parentheses gets taken to the 4th power. So in my head, I'm thinking about this as negative 2 to the 4th power. Now that's not negative 2 times 4, is it? That's negative 2 times negative 2 times negative 2 times negative 2. Or on your calculator, you could do it like that. What is negative 2 to the 4th power? If I need a calculator, guys, you can go ahead and grab one. I'll do it for you. Okay, so we're typing in negative 2 to the 4th power. You have to put it in inside of parentheses. Any negative number. Negative 2 to the 4th power is 16. So I'm going to replace the negative 2 to the 4th with 16. The a inside the parentheses is like a to the first power. So think of that as a to the first to the fourth, which is really a to what power? A to the fourth. And then we have a b inside the parentheses, so that's like b squared to the fourth power, which is really b to the eighth power. So our answers are very different on the two problems, aren't they? Based on where those parentheses or what the parentheses include. All right, let's move on to some more challenging ones. So in this example, we have parentheses, 3xyz, close parentheses, and another parentheses, x squared to the fifth power. We must take care of our exponents before multiplication, just like PEMDAS would suggest. Okay, we definitely have exponents, don't we, as far as a power to a power I'm referring to. What is x squared to the fifth power? X to the 10th. I'm going to bring down the first parenthesis. Times x to the 10th power. Now this is what we did yesterday. If we are multiplying, what did we learn to do? We're multiplying the variables. What did we learn to do to the exponents? We add them. There are no other coefficients. I'll bring down the 3. I have x to the first times x to the 10th, which is x to the 11th. 1 plus 10 is 11. I don't have any other y's or z's, so I'm going to bring that down as y. Z. So do you see what I mean about you really have to understand what we did previously, because we're adding it in today, aren't we? How about this one? Negative 2 in parentheses, negative 2xy, close parentheses, cubed. In the second parenthesis, I have negative 2 squared, negative 2x squared, y to the fifth, all squared. All right, so we have to take care of our exponent first. I want to look at this first parenthesis. That 3 is zinging that whole parenthesis, so everything inside that first parenthesis gets cubed. What is negative 2 cubed? Not negative 6. Take it on your calculator. Negative 2 caret. Negative 8. It's negative 8. X is inside that parenthesis, so it gets cubed. So it's simply just x cubed. Y is in the parenthesis. It gets cubed as well. So just y cubed. That's the first parenthesis. Now the second parenthesis, we are squaring everything inside. So what is negative 2 squared? Negative 2 squared. On your calculator, what's that? 4. Now I've got x squared squared. X squared squared is really what? X to the fourth. I have y to the fifth squared, which is really y to the 10th. Am I finished? No, I can keep going. I have variables with a common base. I have coefficients. I can simplify. What are we going to do with negative 8 and 4 there? Multiply them. They're coefficients. They're big numbers. They do what big numbers do. They multiply. Negative 8 times 4 is negative 32. What is x cubed times x to the 4th? X to the 7th. 3 plus 4 is 7. Y to the 3 plus 10 is 13. guys hanging in there so far? Feel like it'll follow along? Please stop me if I ever say something that doesn't make sense or move too quickly. Alright, I've got 3 more examples. Give you a second to copy that one down and then we'll talk about it. So that first parenthesis, we need to cube everything, correct? You have to take care of that outside exponent first. So 2 cubed is going to become, what's 2 cubed? You guys should know that. 2 times 2 times 2, it's 8. A is in parentheses, so A cubed is A cubed. B is in parentheses, so B cubed. I basically distributed that exponent, didn't I? I took everything in that first parenthesis to the 3rd power. Second parenthesis, third parenthesis, those stay the same, so I'm going to bring them down. I always try to take care of my coefficients first. Coefficients are big numbers. They do what big numbers do. What are we going to do with these big numbers? Multiply them. Now, multiplication is commutative. I'm going to do negative 4 times 5 first. Negative 4 times 5 is negative 20. What's negative 20 times 8? Well, what's negative 2 times 8? Negative 2 times 8 would be negative 16. Add a 0. I have a's, I have a cubed, and I have a squared. What is a cubed times a squared? A cubed times a squared. A to the 5th. 3 plus 2 is 5. I have b cubed and I have b squared. B cubed times b squared. B to the 5th power. About this one. In parentheses, we have 16mn squared times parentheses, this 1/4, the whole fraction there is in parentheses. 1/4 m cubed n to the 5th all squared. I always want to take care of those outside exponents. The outside exponent I'm referring to here is 2. Let's square everything in the second parentheses. The first parenthesis, I'm just going to bring it down. Alright, so how do you square 1/4? Easy. Just square the numerator and square the denominator. What's 1 squared? 1 squared is? 1, right? Is it 1 squared? 1 times 1? Right? This 1. And then 4 squared, 4 is in parentheses, so it's getting zinged. 4 squared is? 16. We have 1/16. And leave it as a fraction because it's going to work out nicely when we multiply it by 16 here in a second. 1/16. In that second parenthesis, I have m cubed squared, which is m to the 6th power. We have a power to a power. We learn to multiply. 3 times 2 is 6. When you write m to the 6th, do not put it in the denominator. Either put it beside this fraction or put it in the numerator of the fraction. Do not put it in the denominator. N to the 5th squared. N to the 5th squared is going to become n to the 10th. Took care of my outside exponent. I squared everything in parentheses. Now, let's just multiply. What is 16 times 1/16? It's 1. A number times its reciprocal always has a product of 1. What is m times m to the 6th? M to the 7th. That's a 1 there, right? 1 plus 6 is 7. What is n squared times n to the 10th? N to the 12th. 2 plus 10 is 12. And I want you guys to go ahead and rewrite this. Let's put it as m to the 7th, n to the 12th without that 1 in front. All right, I've got one more. This will be our last example for today. Go ahead and copy that down, please. Do you agree we have some outside exponents need to be simplified? Start with those outside exponents so you can clear them out and you can just multiply what's left. Is the -4 here in front being zinged by anything? Nope, just bring the -4 down. Now, in the second parenthesis, the 2 is being zinged and so is the 5. So what is 2 to the 5th power? It's what? 32, isn't it? 2 times 2 times 2 times 2 times 2. X to the 5th power, it's being zinged. Okay, the next parenthesis, the 3 is in parentheses, so it's being zinged. It's going to be squared. What is 3 squared? That's 9. Next we have x to the 4th squared, which is going to become x to the, is it 6 or is it 8? 8. 4 times 2 is 8. And then we have y squared, which is going to become y to the 4th power. Taking care of all of our outside exponents, now just multiply. Let's start with our coefficients, our big numbers. Big numbers do what big numbers do. They multiply. I don't have a trick for multiplying these guys. What is -4 times 32 times 9? If you do any calculator, you can do. -1,152. I have x to the 5th times x to the 8th, which is x to the 13. 5 plus 8 is 13. And I have y to the 4th, no other y, so I'll just bring that answer, or that variable down. Alright, so today we learned that if we have a power and we raise it to another power, what are we going to do with those exponents? Multiply them. Real quick, I lied, I do have one more example. What if we had something like that? I can see them giving you that on the EOC. What would you do? Can you guess this?
2 times 3.
Yeah, just multiply. Power to power to power. 2 times 3 is 6. So we could think of that as x to the 6th to the 4th power, which then what would we do? It would be x to the, x to the 24th. We'll get more into examples like that a little bit later. Alright, that's all I have for today's notes. If we have a power to power, we know we're going to multiply those exponents. If we're multiplying our bases, we'll still add the exponents. Today's homework is going to be on a handout like it was yesterday. I'll put it on Google Classroom. If you don't have internet access at home, please make sure you do copy it down before you leave today.